In this segment of video, we're going to speak about how we add perchloric acid. We add perchloric acid to drive off any of the remaining fluoride from the HF dissolution. The equipment setup for perchloric acid is really simple. We start with a repeating pipette. Next to that pipette, we have a beaker of perchloric acid from which we draw the acid out, and we have another dry beaker in which we leave that repeating part of the pipette, the thing at the bottom there, so that we can take the mechanical pipette out of the hood. Because if we were to leave it in there, the acid fumes would destroy it. We have a spill tray in which these two pieces sit, just in case somebody makes a mistake. And we have a hot plate, again, with the beakers on it and its ability to retain the beakers, and in this case, really importantly, to get hot. So that piece of actually solid graphite coated in Teflon on top of the hot plate holds the beakers, surrounds them, and keeps them at that 230 degrees Celsius, so they'll evaporate. The process is relatively straightforward, but very hazardous. It relies on perchloric acid, which is a strong oxidizer. Therefore, we wear full protective equipment at all times. After digestion in HF, the cations in our sample, such as beryllium, aluminum, titanium, iron, and the alkali metals, are bound up into compounds with the fluorine ions from the digestion. Some of these are very strong bonds, and none of our chemistry will work properly if the cations are trapped this way with the fluorine. So the goal of this process is to break up the fluoride compounds by forcing the cations to bind with perchlorate, a form which we can more easily exchange later with other negative ions, such as chloride. Over the course of about 36 hours, we add and evaporate perchloric acid 4 different times. We've tried cutting this down to 2 or 3, and it just never works right. The first time is at the end of the aliquot method, which we detailed in the previous video. The next 3 times occur on the following day and over the course of the subsequent night. Evaporations occur at a very high temperature, about 230 degrees Celsius, in order to drive off the fluoride. The perchloric acid fumes off from the samples in a billowing white cloud. At the end of the process, the samples are very small, usually brown or red, dime-sized cakes of cations bound into perchlorate salts. The blank is usually bright white. From here, we will force these cations to bind with chloride, that's the next video, which will enable us to start isolating the cations based on their size and their charge using column chromatography. The most important things for perchloric acid treatment: we wear full protective gear, we treat the samples multiple times, and we heat the samples to 230 degrees Celsius so that we break that fluoride bond with the other compounds. And this process takes about 36 hours. Afterwards, we've reduced fairly large-looking samples to small, sort of dime-sized cakes of material, which we will then add hydrochloric acid to in the next step and begin the cation column process.